In this video, I'll demonstrate how to plot a parabola using Webassign's graphing tool. And we also want to plot a line that touches 2 points on the parabola. Now, Webassign is very picky about this question, and a lot of people ask me, how do you enter it correctly? One thing is you cannot enter points. All right, so that's one of the biggest problems that I see is that people will put points around the graph and then try to connect them. Unfortunately, you cannot do that. So even though it could make sense mathematically to put points down, Webassign cannot accept those. Okay, so we'll just clear that. For a parabola such as y equals x squared plus 4, you actually want to click on the vertical parabola tool. And you have to click it twice here to activate it. Now it's going to let you put down a vertex and then one other point on the parabola. The vertex being the minimum or maximum of it. So you may wish to, on the side, just come up with a table for this function, such as this. We'll plug in some x values and then we'll calculate the y values that go along with it. So our graph only goes from -1 to 2, so we might do -1, -0.5, 0, 0.5, 1, 1.5, and 2. So if I enter -1 into the formula here, I get 5 as a result. And you just want to keep entering the different x values until you have several coordinate pairs that you can see are on your parabola. Alright, so from my table here, I see that I've got the points -1, 5, -0.5, 4.25, and 2, 8. So we definitely want to use the vertex. So if you're not really sure what this looks like, then you could go to a graphing program such as Desmos.com. Okay, on Desmos.com we could just type in the points that we had found as one option. If you plot all the points you had found in your table, you'll see that the parabola shape is formed here. And all of these points should be on your parabola. To check that, we can type in the formula of the parabola, y equals x squared plus 4. The plus 4 shifts it up vertically. And we can now see that 0, 4 is clearly the vertex of this parabola. That's the turnaround point, the minimum of it in this case. And also it's the vertical intercept of the parabola. And so that's what you actually want to click on first when graphing your parabola in Webassign. So click here at 0, 4, and then just click any other point on your list. So I'll go with 2, 8. There's the parabola that we're looking for. Over here on the right, there is an option to edit the points that you had entered. So here you can manually move the points. Okay, I actually like the points that I had put, so I'm just going to keep them. And now we just have to do one more thing. We have to draw a line between 2 points on the curve. So we want to start on the curve at x equals 1 and go to a point on the curve which is at x equals 2. So luckily here I already have a point that is at x equals 2. Okay, remember you can't click this and add more points. Even though mathematically it wouldn't be wrong to put a point on that parabola, Webassign will not accept it. So I have to remove that. These are points that Webassign had put down as part of my parabola creation, so it won't have a problem with those two. So you just want to remove, if you do see any points on your response here, you just have to delete that, remove that. Alright, so now we want to go from x equals 1 to x equals 2. If I go back to Desmos, the points that they're talking about on the parabola are this point here at x equals 1 and this point here at x equals 2. And it wants us to draw a line between those 2 points. Okay, so that's all you have to do is now select the line tool. And even though when drawing a secant, it could make sense to use a segment, Webassign will not accept that. It wants a line. So just click a line there, and then we can draw a line which goes from x equals 1, so that hovers above the 1 here, and then we want to go to x equals 2. The point where we hit the curve has to be above the x equals 2 on the horizontal axis. That's what Webassign wants for that part of the question. You can edit your line if needed by clicking on this dialog box up here. I actually think these points are good. I see right here I found the point 1, 5 as being on my parabola. I also see here's the point 2, 8. That's on my parabola as well. So these points are actually perfect for what it wants. Now I have to calculate the slope of the line that I created. So to do that, we just use slope formula. M equals delta y over delta x, which is going to be y2 minus y1 over x2 minus x1. So I want to use these points. This is going to be my x1, y1, and this can be x2, y2. So my slope is 8 minus 5 over 2 minus 1, that's 3 over 1. So my slope is 3. Okay, it accepted all that. Now I want to go down to the next graph and actually just draw the same function here. So we want to go from 0, 4, the vertex, and then pick any point that the parabola goes through. It's going to create a vertical parabola dialog here, and this looks good. Now you want to select the line tool again. But here we're going from a x equals 1 to a x equals 1.2. So I can't just go from here to here anymore. We want to shrink that second point down so that it's closer to the first point. Now you could try to move it manually like this. The problem is it's only letting you do 0.1, so 1/10 increments on the vertical here. So it's possible that you won't actually hit the curve exactly where that point should be. You have to actually edit it over here manually. Now how do you know exactly what height that second point should be at? You want to plug 1.2 into your original function. So you've got the formula y equals x squared plus 4. So you want to do y equals 1.2 squared plus 4. Do that on calculator. And it's given me a result of 5.44, which is close to what I had put, but is not exact, and Webassign needs it exact. So the point we need is 1.2 comma 5.44. So we'll just go to the dialog box here and edit that, and now it is perfectly on the parabola. The slope of your line is going to change a little bit, so we want to calculate the new slope. For that, we would do 5.44 minus 5 over 1.2 minus 1 and get the new slope. I get 2.2. Okay, it accepted that. Now we're asked to graph what's called a tangent line to the curve at x equals 1. So this is a little different. We still want to draw the original parabola, but this time when we do our line, we're not going to go through 2 points on the curve. We're actually going to just touch 1 point on this parabola. And what it has to be is it has to be a line that has a slope that's the same as the slope of the parabola at this point, 1 comma 5. So for that, what you try to do is make a line where it seems like it's going at the same angle as the curve is at that location. This looks good to me. An example of a bad response would be something that goes like this. That is not a tangent line. It is a line that touches the parabola, but it's not going at the same angle as the parabola. So you want to look at the steepness, right? So if I was, let's say, if I was walking here, like on a profile of the ground, then the hill is not too steep. But if I'm walking on this here, this straight line, that would be super steep. It would be really difficult to walk on that hill. So they don't have the same steepness. This would be steeper than the parabola. We need them to have the same steepness though. So if I have a straight line that's going at the same angle as the parabola, then they have the same steepness. At that point at least. That's what we're looking for. So it won't accept this. It won't accept something like that. It's not the same angle. Instead, it's gonna want something like that. All right, let's submit that. Okay, it accepted.